today is a very important topic. Probably this course depends mainly on our topic today. Just to remind you, last meeting I started with introduction about this course. I went through what is the meaning of stress strain curve for steel, and I focused on 3 mechanical properties: yielding stress, ultimate stress, and Young's modulus. And also keep in your mind that stress strain curve for steel is identical in tension like compression, no difference. We have different types of steel. Based on the type of steel, I can figure out the yielding and ultimate stresses. And also, whatever the type of steel, Young's modulus E is constant. Whatever the type of steel, Young's modulus most of the time is equal. Also, we went through what are the different shapes of steel cross sections. We have 2 main types: hot rolled steel section, like W shape, like American standard, like angle shapes, channels, structure T, and different shapes like pipe, hollow section, blades, rod, or bars. And we can build something called built-up sections. You can combine different shapes in one cross-section. This cross-section can be called built-up sections. Probably we need this built-up section for heavy structures like bridge, probably high-rise building. I cannot get the required cross-section from the manufacturer, so I build it in my project or during my project. And we have another shape or another type called formed section for very thin sections. We can deform these cross-section without heating. And we learned we reviewed the design philosophy. Design philosophy means we have design strengths and we have ultimate applied load. The design strengths must be equal or greater than the ultimate load, the ultimate applied load on the structure. According to American Society of Civil Engineers, we have load combinations. As you know, we have different types of load: dead load, life load, wind load, earthquake, snow load, earthquake, rain or ice load. All of these type of load, we can combine them together according to these 7 combinations. Which combination I will use based on the maximum value you can get. Today, our topic is talking about steel building layout, mainly warehouse. If you have a storage, if you are a warehouse, if you are something like this, how can I lay out or I set up the layout for this building? Please pay attention to me. Components of steel building layout. The first component, which is called main system. The first component can be called main system. And this main system can be a truss or can be a frame. This main system can be a truss or can be a frame. As you see from these two pictures, if your main system looks like a steel frame, so we have this steel frame, this one. Frame looks like this, supported here by foundation. This main system is repeated in the longitudinal direction of the area of land, and the distance between each main system ranges between 15 to 30 feet, probably 15, probably 20, 25, 30, probably 35, that's fine. But I'm telling you what is the common range for the distance between main systems. So the first component of the steel building layout is called main system. This main system can be a frame or can be a truss, steel truss. We have different shapes of truss. Probably your truss looks like this, something like this. Supported here and supported here. This main system or this truss is repeated like this. We have one truss here. We have another 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 truss here. And so on. The distance between the main system, the distance between trusses, the distance between frames is ranged between 15 to 30 feet. Any questions so far? Any questions so far? Let me know if you have any question. So the first information, your main system probably is a frame or truss. Frame or truss. This main system is repeated. Every probably a range 15 to 30 feet. Hey guys, the distance between main system is constant, uniform distance. So probably the distance is 15. So 15, 15, 15, 15, 15 to the end. Or 20 or 25. I gave you a range between 15 and 30. You can choose what you want. And keep in your mind, it's very important for this point. If you have area of land like this, we have 100 feet long and 30 feet width. So can you tell me, and your frame, I'm selecting a frame. So how can I put this frame? This one is plain. How can I lay out the frame? Do you think your frame looks like this and the span for this frame will be 100 feet? Or a frame like this and your span will be 30 feet? What do you think? It's a good point. Do you think your frame will be spanned between this side and this side? Or do you think your frame will be spanned between this side and this side? Which span you will use? You should have a logic. Thank you. Thank you, guys. Thank you, Oliver. Thank you, Burak. That makes sense. From structure analysis that we learned last year, this frame is not economic. Because if you have larger span, you will have huge bending moment diagram, shear force diagram, and the normal force diagram, and you need a huge cross sections to design this frame because your span is 100 feet. It's too much. but I will select 30. So your frame will be spanned from this side to this side, from this side to this side, from this side to this side. And your distance, your spacing between main system, what do you think? Which value I will use? You have a range, 15 to 30. But keep in your mind, I would like to select a spacing that can fit for 100 feet. If you select 30, so 30 and 30 and 30, 30 plus 30 plus 30 is 90. So the end will be 10 feet. That doesn't make sense. I would like to choose equal spacing. So what do you think? I believe the perfect spacing will be 20, will be 25. So 100 can divide by your spacing. Okay? We will focus on this later a little bit. But firstly, we have something called main system. This main system can be a frame or can be a truss. We have a spacing S between the main system. Okay? Thank you. Yeah. Okay. The second component, something called purlins, or we can call it secondary beam. Secondary beams. If I go back to this isometric, and I would like to show you what is the meaning of purlins. Guys, can you watch this beams connecting between this main system and the following one? We have secondary beam connecting between main systems. These secondary beams is continuous to the end of the building. These beams can be called purlins. The purlins are supported by the main system. That makes sense. So these secondary beams are supported here on this main system and here on this main system, on main system, main system, main system, and so on. For this one, we have secondary beam. Can you watch these lines? These lines can be called purlins, supported by this truss and this truss and this truss and this truss and this truss. So purlins are supported by main system. So the second component, it's called purlins or secondary beams. These purlins are supported by the main system. So my question is, how many purlins I need? What is the space? What is the distance or the spacing between purlins? It depends. If you have a frame like this, I will put my purlins with spacing between 5 to 10 feet. So the first purlin, the second one, the third one, the fourth one, the fifth, the sixth, the distance between these purlins ranges between 5 to 10 feet, as you like. You can select any spacing between this range, 5 to 10. If you are talking about frames, I will select this spacing between purlins. If you are talking about a truss as your main system, like this, we don't have a choice because your purlins will be located at each joint. Can you see here? I will make it bigger. Can you see? This purlin, this purlin, this purlin, this purlin, this purlin, this purlin. Each purlin will be located at each joint on the truss. We don't have a choice to select spacing 5 or 10 or 8 or 6 feet. No. You have a truss like this. We don't have a choice to locate purlins because your purlins must be located at each joint of the truss. That makes sense? So, case of trusses located only at the upper joint of the truss. If you have joint, you have purlin. 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 But if you are talking about frame, we don't have joint in the frame because frame is one beam like this and one column like this. So where can I put the purlin? We can choose a spacing between purlins like 5 or 6 or 8 or 9 or 10 feet, whatever the spacing. In your, just for your information, purlins looks like channel cross section like this or Z cross section like this. A very, very thin cross section and cold formed section. These components are made from cold formed section, are very thin. Any question? Any question? So, main system, probably truss or frame, spacing between main system 15 to 30 feet. Between main systems, we have secondary beams or called purlins. These purlins are supported by the main system. How can I locate the purlins? Based on if you have a truss, so at each joint, we have a purlin. If you have a frame, we can locate purlins by spacing between 5 to 10 feet. Then, we have covering sheet. So guys, one more time. This house or this building, we have main system here. Looks like frame. Can you see? We have another frame. I believe we have another frame here. We have another frame. We have another frame. These frames can be called main system. In this case, we have a frame as a main system. Then we need to locate something called purlins, which is this one, this one, this one, this one, this one, this one, this one. That makes sense? These are called purlins. The spacing between purlins ranges between 5 to 10 feet. On the purlins, we have something called covering sheet, corrugated steel sheet. Corrugated steel sheet, roof panels, is used in this covering. This corrugated steel sheet is supported by the purlins. So this one is covering sheet. Looks like this one, corrugated sheet. Is supported by bolts or rivets on the purlins. So, to summarize what I explained, we have corrugated steel sheet supported by purlins. We have purlins supported by main system. We have main system supported by foundation and spaced in a range 15 to 30 feet spacing. Any question, guys, so far? Guys, this point is very important. we need to understand the different component of our steel structure. These are the main components: main system, purlins, and the corrugated steel sheet. With these components, you can form your steel structure. Any comments so far? Okay, looks good. What is the next component? We have something called side girds and end gable. Side girds is a beam, but on the side of the building. I understand that this beam, this one, this one, and this one, and this one, and this one, all of these beams can be called purlins. What about the beams on this side? The beam on this side? The beams on this side? Or beams on this side, this side, this side, and this side? These beams can be called side girds. Side beams supported between columns and end gable around the building. I cannot catch what is the meaning of end gable. Okay, let me explain it. Guys, these side girds, these side beams, supported by what? Can you answer me? From this isometric. Just to remind you, we have main system, looks like frames. This main system is repeated as you see. Can you tell me these side girds are supported by what? Thank you, Brock. Yes. Thank you, Oliver. Yes. These side girds are supported by the column of the main system. That makes sense. What about these side girds? We don't have column in between. We should. We don't have. We have one column here and another column at the end, and we have this main system for this frame. It's too long, 30 feet, 50 feet, 100 feet probably sometimes. So it's too long to leave these beams without any intermediate support. So I will add intermediate column. These intermediate columns can be called end gable. So end gable is a column, but a column on this side of the building only, and on the other side of the building only. They are not repeated inside the building because you have open area inside the building. So side girds supported between columns and end gable around the building. Vertical distance between side girds, I will repeat them. The vertical distance between side girds, between 5 to 10 feet. End column or end gable, I can repeat them every 10 to 25 feet. So these are the main component of the steel structure. I would like to repeat them here on this. Probably on this one will be better. Guys, we have main system repeated like this. Between the main system on the top of the roof, we have purlins. On these purlins, we have corrugated steel sheet. On the side of the building, from this side or this side or the other side or this side, we have side girds, these horizontal beams. From this side, they are supported by the column of the main system. From this side, these horizontal beams are supported by something called end gables. Then you are done with the steel structure. Any questions so far? Looks good. Next, we have two more components. The first one can be called horizontal wind bracing, and the second one called vertical wind bracing. Horizontal wind bracing, for the first panel and the last panel, I will connect crossing like this. These components or these members can be called horizontal wind bracing to connect this main system by this main system to support any wind from this side. If you have wind, you have horizontal bracing or horizontal wind bracing. If you have horizontal wind bracing, we should have vertical wind bracing. I will choose horizontal wind bracing in the building every 50 to 75 feet. So this spacing will be ranged between 50 to 75 feet between this wind bracing and this wind bracing. If your building is larger or longer, I will repeat this bracing one more time. One more time. One more time. The spacing between each horizontal bracing will be around 50 to 75 feet. If you have horizontal wind bracing, which are these crossing, I will have vertical wind bracing. So vertical wind bracing to transfer wind load from horizontal wind bracing to foundation. What about horizontal wind bracing? Horizontal wind bracing to transfer wind load from end gables. We have here end gables. And the vertical bracing. So transfer wind from this end gable to vertical bracing. Vertical bracing to transfer wind load from horizontal bracing to foundation. You have to put horizontal and vertical wind bracing to prevent any collapse due to wind. Can you see? The final layout, just to remind you, your main system probably is a truss like this or frame like this. Then we have something called purlins. These purlins are supported by main system. For frames, we need to select this spacing between purlins. For trusses, we don't have a choice. Your purlins will be located at each joint on the truss. Guys, from this side, we have beams supported by the column of the main system. These beams can be called side girds or beams on this end like this. We don't have here column, so I will put here column. This column can be called end gable. Why they called end? Because they located on this side of the building and the other side, the opposite side of the building. We don't have them inside the building. Guys, at the first panel and the last panel, the first one and the last one, we must have this cross, this cross, this cross, this cross, which called horizontal wind bracing. If you have these horizontal wind bracing, you must have this cross between this column and this column, which called vertical wind bracing. At least you have to put 2 panels at the first panel and the last panel to prevent any collapse due to wind. Make sure the spacing between this panel and this panel between 50 to 75 feet maximum spacing. If you have larger distance, please repeat these crosses one more time inside the building or at intermediate distance. Any questions so far? Any question so far? Okay, let's watch this video and see what's going on.
If you're like me, you've probably tried to learn Photoshop online and found it quite.
Can you see? Starting from foundation, we have footing, we have a steel column, connection to support bracing. These bracing are very important to prevent any collapse. These are called vertical bracing at the first one and the last one. These are connections. We will go through this connection in more detail. Here is the main system. Looks like frame. These are some kind of connection to support purlin. Can you see? So here is the main system. And these are the location of purlins. We have a technique for connection to support purlins. Connection. Horizontal wind bracing. If you have horizontal wind bracing, you have vertical wind bracing. If you have horizontal wind bracing, you must have vertical wind bracing. Make sure you understand this point. Purlins. Purlins. These purlins are supported by the girders of the main system. Can you see the connection? Sometimes we have tie rod to maintain the stability of the purlin. It's not a big deal. pouring concrete for footing, corrugated steel sheet. Can you see the corrugated steel sheet? So keep in your mind, this corrugated steel sheet is supported by purlins. The purlins are supported by the main system, and then the main system is supported by the foundation. Connection between corrugated steel sheet and purlins. Interesting. That's right. So guys, just to remind you, because this point is very important, once you have horizontal wind bracing, you must add vertical wind bracing. Both of them at the same location, both of them at the same panel. Okay? Any questions so far? Any questions so far? If you have any question, let me know. I think we don't need to wait. This is for this video, because this video is not a real video. It's animation video. No, you have to pour your footing and then build your column and then build your main system and the sequence of the different component. No, you have to pour your foundation first, because but this one is not a real video. It's animation video. Okay. So Alan, the first step to pour your foundation. Okay. So guys, I have question. We need to draw 3 main views. The first one called elevation, and we need to draw plane, and we need to draw side view. One without end gable, and the side view with end gable. What you mean? I will explain it in more details, because the first step and the first homework in this course, we need to draw plan, side view, elevation for the layout. So please pay attention to me. Pay attention to me. Elevation means you are standing at this location, watching this building. What you are watching? Can you tell me? What you are watching? I will see this column, this column, this column, this column, this column. That's right? That's right? So we have column, 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 column. I have a question. What is the spacing between each column? What is the distance between each column? The distance between each column is the spacing between each main system. Main system spacing. That's right. And also, If I'm standing here, I'm gonna watch this purlin, I'm sorry, this side girds, this side girds, this side girds. So we have side girds, side girds, side girds. And also, this slope, can you see? This slope, this slope, this slope, this slope, this slope. If you are watching from this side, I'm gonna watch this slope like very little vertical element, like this one, like this one, like this one. That's right. And we have at the beginning, we have here purlin. At the end, we have another purlin here. The purlins in between, I don't care about them. Forget them. In between. So if you are watching elevation, I'm gonna see this shape. Vertical column for each main system. The distance between each column is the spacing between main systems. I'm gonna watch the side girds. I'm gonna watch the top of the building. The purlins on the floor, I will forget them. And also, keep in your mind, at the first panel, I have vertical wind bracing, so I will have vertical wind bracing. At the end, I will have one also. Probably, if this distance is too long, probably I will have one at the intermediate distance. That makes sense? That makes sense? Any question? Guys, I have question. Do you think if I put this vertical wind bracing like this, is it correct? Is it correct to do one cross like this? Do you think it's correct? What do you think? No? No? Yes? Oliver, no. Why? Burak, I don't. Why? I don't, or I don't see why it would be correct. It looks right. Oliver, do you have a reason why this shape is not wrong? Because as you watch here, he put something like this. This cross is alone at this level, and then he put another cross or something like this. So what do you think? I think it's okay. No problem. We don't have issue with one cross like this. The only issue if this height is too high. So this one cross will be too long for this member and this member. We have a concern about buckling because one of them is under tension and one of them is under compression. Anyway, This is the elevation. What about the plane? If you are watching from the top of the building, what you are watching? I will watch this beam, looks like a line, this beam, this beam, this beam, and this beam. The spacing between these beams will be the spacing between main system. And also from the top, I'm gonna watch this Berlin, this Berlin, this Berlin, this Berlin, this Berlin. From the top, I'm gonna watch this cross, which is horizontal wind bracing, this cross, this cross, this cross. So if you are watching from the top, I'm gonna see this shape. The beam of the main system, these lines should be solid, should be thick a little bit. Between these main system, I have Berlin, 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 Berlins, like this. Don't forget, at the beginning or at the first panel, we have horizontal wind bracing. At the last panel, we have horizontal wind bracing. If this distance between this one and this one is greater than 50 to 75 feet, I highly recommend to add another one in between. And make sure and be careful about this mistake. If you have horizontal wind bracing in the plane, you must have vertical wind bracing on the elevation. If you have horizontal wind bracing in the plane, you must have vertical wind bracing in elevation. If you have horizontal wind bracing for the plane, you must have vertical wind bracing in the elevation. One more question, guys, one more question. So pay attention. Do you think I can put this cross? I can put this cross like this. One cross like this one and this one. Is it correct? Because this point is very important. Can I put this cross like this? One cross, not two crosses, like this. And then one more here, and one more here. Or can I put only one cross like this and like this? Or what should I do? Brock, no. It's not yes. Alan, your answer is perfect. Oliver looks like unstable. No. Guys, okay, we can go back to this one. Can you put one cross like this and like this? Does it make sense? We have a ridge here. Can you watch? We have two different levels between this node and this node and this node. How can I make one cross to cover this node and this node and this node, or this level and this level and this level? I cannot. The only option, this side with one cross and the other side with another cross. I cannot do one cross to cover from this side to this side because we have two sloped surface. That makes sense? That makes sense? Okay, no problem. Right now, did you get it? Everybody, did you get it? Please pay attention. I know in the plan, we have this line at the intermediate distance or the mid distance represent this point at the two different slopes, this side and this side, this side and this side, which represent this line. So we have two different slopes, this slope and this slope. So the minimum number of bracing or the minimum number of crosses, I can put one cross here and another cross there. If you are feeling this distance is too long, okay, I will do two crosses, one like this and another one like this. And the same on the other side. If you are feeling they are still too long, we can put 1, 2, and 3. Less distance or less lenses will be more stable because we don't like long members. Long members under compression can cause buckling. We will cover all of this stuff later. Okay? Then finally, can you tell me what is the shape of the main system? You need to tell me what is the shape of the main system. If it's a frame, you need to draw this shape. If the main system is truss, you need to draw the truss. And also you need to draw another main system, but showing me the end gables and the side girds. Okay, so for any layout, I need to watch elevation, plan, main system without end gable, main system with end gable, and side girds. Any question? If you are professional, I would like to see your work using AutoCAD. If you cannot, that's fine. You can do it with your hand, but with your hand, not with your leg. With your hand means you have a pencil, you have a ruler, you have clear sketch. Let me do this example with you. We have a piece of land, 300 feet times 130 feet. We need to cover this area of land by main system or by steel structure, and the main system I will use is this truss. Probably in your exam, probably in your project, I will not give you this main system. You have to choose it. But in this first example, I will give it to you. What do you think? Do you think this main system will be supported from this side to this side? Doesn't make any sense because this span is 300 feet. However, this span is 130. So the logic is this main system will be supported from this side to this side because this distance is 130 feet. So What is the spacing between main system? What is the spacing? I need to cover 300 feet, and the spacing must be in between 15 to 30 feet. Do you remember that? If you go back, the distance between main system between 15 to 30 feet. So I believe we can choose 30 feet, because 30 feet with 300 feet, we can get an integer number of intervals. So the distance will be 30 feet. If you choose 25, that's fine. If you choose 15, that will be fine. If you choose 20, that's fine. You can choose what you want. But I highly recommend to choose a number or a distance can give you an integer number of intervals. So your main system will be like this. I'm drawing a plane, and the spacing between each main system will be 30 feet. For me, I choose 30. Can you tell me where is the purlins? Do you have a choice for purlins? We don't have a choice, because your purlins will be at each joint of this truss. So the horizontal distance between each purlin will be 65 feet. I'm sorry, it's not 65, it's 6.5, because this one is 20 times 6.5 feet equal 130 feet. 20 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 spacing. And 6.5 is the spacing. So we have purlin here. After 6.5, we have another purlin. After 6.5, we have another purlin. After 6.5, we have another purlin. Don't forget, we have a purlin at the midpoint. We have purlins, we have purlins, we have purlins, we have purlins, and so on. I think I will put here, guys, please make sure you are looking for the intermediate purlin. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3. This one is the intermediate one. At the ridge here. So I will put here horizontal wind bracing, 2 crosses like this. Another 2 crosses like this. At the first panel and the last panel, they are the minimum number. Minimum. The first one and the last one. Do you think what is the spacing? What is the total spacing between the first one and the last one? 300 is too much. Too much. Probably I will add another one at the intermediate distance. Probably. Or maybe two more. I am done with the plane. I am done with the plane. The plane showing me what is the spacing. And I highly recommend to add your dimensions here if you are drawing using AutoCAD. For elevation, elevation means I'm watching this side, so I'm gonna watch the column of the main system, and we have side girds. At each location of the horizontal wind bracing, we have vertical wind bracing at the first one and the last one and in between. And then we have a side view for the layout for the main system without end gable and with end gable. So I will add the end gable like this. 1, 2, 3, 1, 2, 3. And side girds, probably. Okay. So please start to do your layout for this example. If you would like to send it to me to highlight what is the mistakes you did, I can. I highly recommend to use AutoCAD to draw your layout. You have many tools in AutoCAD to put your dimensions, to put colors, to put thick lines, thin lines, all of this stuff in AutoCAD. If you cannot, it's okay, but please don't use your hand, just hand. No, you have to use a pencil, you have to use a roller, you have to use an eraser to make sure your sketch is very clear. Okay? The fatal mistake most of the students are doing, if you have horizontal wind bracing on plan, your elevation must showing up vertical wind bracing. Your final layout looks like this. Here is the elevation, then your plan underneath the elevation. So I can look, we have here vertical wind bracing, so we have here horizontal wind bracing. We have here vertical wind bracing, so we have here horizontal wind bracing. We have here vertical wind bracing, we have here horizontal wind bracing. The other mistake the students are doing, please figure out where is the ridge, the intermediate point for your main system. We cannot do cross for horizontal wind bracing like this. Doesn't make any sense because you are talking about two different slopes. Two different slopes. These are the two main mistakes the students are doing. Please try to avoid these two mistakes. So just to summarize what I did today, I explained what are the main components of steel building layout. Main system, purlins, corrugated steel sheet, side girds, end gables, and finally bracing. We have two types of bracing: horizontal wind bracing, vertical wind bracing. Mainly this bracing to support wind loads. To support wind loads, to transfer the effect of wind loads to the foundation. We need to sketch layout for your building. This layout consists of elevation, plan, and the side view. Your side view is identical, but we have a little different. The first one is the main system without anything. The second one is the main system showing up the end gable and side girds. For elevation and plan, please try to put your dimensions, try to put your labels like this. You put axis A, B, C, D in this direction and 1, 2, 3 on the other direction. Something looks like professional.